For this first page of problems on the review, there's three options for how you can solve. So you can use special right triangles, which is only going to happen if you have angles in your triangle that are 30 degrees or 45 degrees. So any problem like that, so that would be like number 1, number 3, 7, 8, and 11 and 12, because those all either have 45, 45, 30, or 60 degrees in them. Problems that only have side lengths besides the 90-degree angle are going to be Pythagorean theorem. So that's problems like 2 and 6. And then problems that have an angle that's not 30, 60, or 45 are going to be our trig problems. So that would be 4, 5, 9, 10, and that's it. So I will highlight those up here. So blue was trig, yellow was special right triangles, and the red was Pythagorean theorem. So tomorrow you'll be given the formulas for these special right triangles, and we know how to label those because across from 30 is the side that's x. The hypotenuse, which is across from the right angle, is always 2x. The third side's always x radical 3. So just as a reminder, you're always going to start by filling in those labels. Since right here I have that the 2x side is 24, I can go ahead and just solve for x, and I figure out that x is 12. And then once I have x, I can go ahead and take it, and I can plug it back in everywhere in my formula that I have written an x. So for example, this side over here, when I plug it in, is 12. So the y variable is 12. And then this side right here, when I plug it in, is 12 radical 3. So the x variable is 12 radical 3. For number 2, this is Pythagorean theorem, again, because there's no angles given except the right angle. You can label A and B like either way, but the hypotenuse has to be C. So this problem would be set up something like this. Pythagorean theorem, in case you forget, is a squared plus b squared equals c squared. That won't be given tomorrow, so you do have to have that memorized. So when I plug it in, it looks like 5 squared plus 7 squared equals x squared. 5 squared is 25. 7 squared is 49. And then I add those two together, and I get 74. To solve for x, I have to take the square root, and you're welcome to just leave it as square root of 74 unless it says round to the nearest tenth. For number 3, this is a 45, 45, 90. So this side across from the right angle, the hypotenuse is x radical 2. The other two sides are x. We can go ahead and set these two equal, and then I'm just going to solve for x by dividing by radical 2. That just causes these to cancel out, these to cancel out. X equals 27. I'm going to go ahead and take that and plug it back in to my other two sides. So plug it in here and here. So both of those sides are 27. Problem 4, since I have an angle that is not 30, not 60, not 45, that makes this a trig problem. So we're going to mark our angle. Across from the angle is always the opposite side. The hypotenuse is always across from the right angle. The last side's always adjacent. Since there's nothing over here on this adjacent side, I can go ahead and erase that. I'm not even going to look at it. Again, trig formulas will be given tomorrow. O and H go with sine. So you fill it in, sine, and then the angle equals opposite over hypotenuse. Since 40 is in the denominator, to solve for x, we would multiply by 40 on both sides. And then you go ahead and just type this into your calculator. So it's about 38.6. Number 5 is also a trig problem, so it starts off the same way. Mark your angle and start labeling. Across from our angle is O. Across from the right angle is the hypotenuse. The third side we label as adjacent. Since there's nothing on our hypotenuse, I can go ahead and disregard that. O and A go with tan. Since X is in the angle, we are doing the inverse, so tan with the little -1. O goes on top, A goes on the bottom. Type it directly into your calculator. And this will get you 33 degrees. Number 6, again, no angle is given except the right angle, which makes this Pythagorean theorem. Across from the right angle is the hypotenuse, which we have to call C. A and B can be interchanged. Pythagorean theorem is a squared plus b squared equals c squared. And then I just fill things in. So 40 squared plus x squared equals 50 squared. 40 squared is 1,600. 50 squared is 2,500. To solve, I need to get x squared by itself. So I'm going to subtract 1,600 from both sides. X squared equals 900. To get x, not x squared, I'm going to take the square root, and x ends up being 30. Number 7 is one of our special right triangles. So this is x radical 2. X radical 2 always goes on the hypotenuse. I have that x is radical 6. So I go ahead and I take that and I'm plugging it in to both of these x's. So over here, I get just radical 6. But when I plug it in right here, I get radical 6 times radical 2, which gets me radical 12. Radical 12 can be simplified because it has a perfect square factor, and that would be 4. So I can break it into 4 times 3. Radical 4 is 2, so this is really 2 radical 3. Number 8 is another special right triangle. So x, the hypotenuse is x radical 2. This time I'm solving for x, so I would do that by dividing both sides by radical 2. So I have x equals 34 divided by radical 2. However, you can't leave a radical in the denominator. And we fixed that problem by rationalizing, by multiplying by radical 2 over radical 2. 34 and radical 2 can't be combined because they're not both in a radical or both out, so it's just 34 radical 2. And then square root of 2 times square root of 2 is square root of 4, and the square root of 4 is actually just 2. Lastly, 34 divided by 2 is 17, so x equals 17 radical 2. And then I go ahead and I just plug that in to both of these sides. Number 9 is just a trig problem, so we start by labeling. Across from the angle is O, across from the right angle is H, the last one is A. Since O has nothing with it, I'm going to go ahead and disregard it, and AH goes with cosine. So cosine 28, adjacent on top, hypotenuse on the bottom. To solve for x, I multiply both sides by 39. When I type this into a calculator, I get 34.3. Number 10 is another trig problem. Again, start by labeling. Across from the angles O, across from the right angle is the hypotenuse. Since I have O and H, that goes with sine, so it's sine the angle, which is 48, O in the numerator, H in the denominator. Remember, if x is in the denominator, it ends up just flipping these two. So I have x equals 40 divided by sine 48, which is 53.8. 11's another special right triangle, so remember across from 30 is x, the hypotenuse is 2x, the last side is x, radical 3. X radical 3 equals 42, and then I just start solving for x, which I do by dividing by radical 3 on both sides. So right now, x equals 42 over radical 3. Can't leave a radical in the denominator, so we do radical 3 over radical 3. So now I have 42 radical 3. Radical 3 times radical 3 is radical 9. The square root of 9 is 3. 42 divided by 3 is really just 14, and so x equals 14 radical 3. So I go ahead and I plug that back in to both of these x's. So here I have 14 radical 3. Here I have 2 times 14 radical 3, and 2 times 14 is just 28 radical 3. So in my y answer blank, I put 28 radical 3. In my x answer blank, 14 radical 3. And then the last one on the front, again, is a 30, 60, 90. So this side is x, this is 2x, this is x radical 3. I have that x equals 15. So I'm going to go ahead and take that and just plug it in to both of these sides. So when I plug in here, I have 2 times 15, which is 30. When I plug in here, I get 15 radical 3. So 30 goes in the y blank, and 15 radical 3 goes in the x blank. I'm not going to take the time to go through a video for the rest of the review, just because it really is reading and drawing out those story problems. So you can check out those answers on the written key. And if you have any questions, just send me an email.